Statistics catches killers. Can you believe it? Hello, welcome back to the Quant Plus YouTube channel. Suppose we are given the following information. We know that in an average shift in the ER, we expect about half a death, which translates to we expect about one death every 2 shifts. Suppose that for a particular nurse, we found that during their shifts, there were 0.8 deaths per shift, with a standard deviation of 0.1 deaths per shift. And let's suppose that we observed them for 49 shifts. Do we have reason to suspect them of foul play? Well, maybe, but maybe not. Let's translate this into the language of statistics and see what we can come up with. I'm going to treat this as a hypothesis test, with the null hypothesis being mu equals 0.5, translating to this particular nurse is innocent. They're just unlucky, and for some reason, people tend to die. Versus the alternative, mu is greater than 0.5, indicating that they might be doing something funny. Well, in this case, we're going to use the following t-score formula: x bar minus mu divided by s over square root n. Looking in our numbers, we see that in this particular nurse's shifts, we see 0.8 deaths. On average, we expect 0.5. Standard deviation is 0.1. And we are dividing by the square root of 49. 21. Then our degrees of freedom formula is n minus 1, because this is a one sample hypothesis test, or one sample t-test. So we get 49 minus 1 is 48. Or our p-value, right? The likelihood of seeing such an extreme observation if the null hypothesis holds translates to the probability of t being greater than 21 if you have 48 degrees of freedom. Now, I don't have a calculator or t-distribution table in front of me currently, but this is such a large t-value that this probability is indistinguishable from 0 unless you have an extremely powerful computational tool. But in most cases, this is going to be indistinguishable from 0, making it almost impossible that the null hypothesis is true. So to wrap this up in terms of the language of statistics, we're going to say that we reject our null hypothesis and instead tend to favor our alternative hypothesis. I'm using that particular terminology because even though our p-value in this case came out to be 0, this is not conclusive proof in favor of the null hypothesis. It only is showing that it is the far more likely scenario between our null and alternative hypotheses. In the real world, there were several such cases, of which the details are currently escaping me, but they did very similar analyses, and the statistical analysis was then used as probable cause, launching a further investigation leading to murder indictments. So, if you found this content interesting and would like to support the channel, please like this video, subscribe to the channel, and share it with your network. If you're interested in one-on-one tutoring sessions, please follow the link in the description. Have a great day.